Okay, this will probably be one of the easiest videos you guys will get to watch. Something super simple that you guys are already really good at is nets and views, and there's just a few problems on the notes for nets and views. Um, we're looking at three-dimensional figures in this new unit, so we're just going to start with just some building blocks here. And this first question just asks us, what is the fewest number of cubes needed to construct a solid figure with the following views? Okay, so with a front, has 1, 2, 3, 4 across the front. So this would be the front facing us 1, 2, 3, 4. Um, a stack of 2 in the back, second row, and then 1 behind that. Okay, the side view, that would be the right side over here. 2 tall, then 3 tall, then 3 tall, then 1 tall. 2 tall, 3 tall, 3 tall, and um, 2 tall. The top view is so that would be the shaded part on top here. 2, 2, 1 and 1. And then there's 2. Obviously, we can't see something else that's back here. And then this guy is 4 across the top. 1, 2, 3, 4. Okay, so we need to know what is the smallest number needed to make? Well, right now we could just simply count how many we can see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, but remember, there was 1, for example, on the side. There were 2 here, and there's only 1 that we can see here. So there's obviously something behind here that we can't see. And also with this guy from the top, there's 2 here, 1, and then we can only see 1 on the third row here. So there's got to be 1 back here we can't see. So the smallest number we can make, since we can only see 14 of them, but we need 1 more to make that stack, we would have 15. Okay. Now most of these guys are not that difficult. Draw the top, front, and side views of the following figure. Okay, the top view. So we're looking basically straight down at this figure. I'm going to go ahead and shade what the tops. Oops, let me pick a different color. So here are the tops. We're looking straight down on it. There's 1 back here you can barely see. Okay, so the top view, if we were drawing it, would be 2 here, then 1, 2, 3 across the top, and then 2 more on the last row. So if we're looking straight down like a bird's eye view of the top, it would look like this. Okay, so from the front, I'm going to go ahead and erase this shading, pick a different color for the front. So the front is looking straight at it. So the sides that are facing us are these 3 across the front, and then this guy that's sticking straight up. Okay, so we have 3 and then 1 on top of the middle. So your front view would be 3 across the front, and then 1 on the middle. So this section here in the middle is 2 tall, and these are only 1 tall each. Okay, and the right view. So if we were coming at this shape from the right side, so looking at it from this direction, I'm going to pick a different color. So all the right faces, I'm going to color in. So if we were to turn that shape to us, we would see 1, 2, and then 3 across the bottom, but we wouldn't be able to tell that this one is 1 deep, 1 deeper than these 2 on the front here. So it would just look like 3 straight across from the right side. And then again, there's this 1 that's on top of the middle one that we can see. So 1, 2, 3 across the bottom, and then 1 in the top middle. Okay. All right, so here's a 3-dimensional figure here. It's called a frustrum. The new recreation center is in the shape of a frustrum of a square pyramid. A frustrum is the part of a solid that remains after the top portion of a solid has been cut off by a plane parallel to the base. Basically, this used to be like a pyramid, and it just got cut off. Okay. A 3-dimensional representation of the recreation center is shown to the right. So this is the rec center here. Which figure could represent the recreation center when viewed from directly above? So again, we're looking straight down at the rec center from the top. So we're looking down at it. So obviously we would see the top. Okay, so we would see a square. So the top of this is a square. But we would also see how it's bigger at the bottom. We would see that a little bit sticking out, looking straight down at it. And then we would see the edges of the base, just like that. Okay, so obviously this shape looks like B, looking straight down at our square pyramid. It has been cut off from the top. Okay, this shape is a lot easier than the one we did at the very beginning. Which of the following is not a correct lateral surface of the solid picture? Okay, lateral surface just means around the figure. Okay, so not what's inside, not the volume or anything like that, but actually the faces that we can see. Okay, so if we checked A, let's start going. Do we see a face that has 3 across the bottom and 2 on top on the right? Well, I do. I see 1, 2, 3 across the bottom, and then 1, 2 on the kind of right side. So looking at it from this direction. So it's not going to be A because we're looking for which one is not going to work for us. Okay. How about this shape? Okay, it looks like it from facing the top, you can see that. 1, 2, kind of in a horseshoe. It doesn't matter that this is taller than these. If you're looking straight down at it, you won't be able to tell that one is taller than the other. You would just see this. The horseshoe kind of effect. So it's not B. Okay, what about C? It looks like we would be able to see C from the right-hand view. The right face gives you kind of that L. So hopefully it's D. Yeah, the reason it can't be D is because there's a hole right here, and if we look straight down at it, there would be a hole. So that this is an extra block that we don't see in this shape. So our answer to this is D. Okay, moving on to the back. All right, the drawing to the right shows the top view of a solid figure made of stacked cubes. So this is showing us by looking at that this would be the front. This is how many cubes would be in each stack. So this one would be 2 tall. This would be 3 tall, 3 tall, 4 tall, 5, 4, 3, 3. So we need to match one of these to our to what this is telling us here. So we need to make sure that our stacks match this. Well, I can tell you that D is automatically out because if this is the front, we have nothing here. And we need 2 and 3 as a stack here in the corner, which we don't have. Okay, so here's a front. Let's start just with this front right here. 2, 3, 3, 4. 2, 2, 3, 3. So that's not going to be it. Okay, our front here. 2, 3, 3, 4. This is 2 tall, 3 tall, 3 tall, 4 tall. Okay, good. Let's check the second row. 3, 3, 4, 5. 3. Same one here. 3. This is one higher, 4, and one higher, 5. So we're good there in the second row. And the last row, 3, 4, 4, 5. 3, 4, because it's one higher than a 3. 4, because it's the same height. And 5. So B would be our answer here. And our last one, the figure is composed of cubes. Which diagram could represent the top view of the solid figure? So we're going to go ahead and shade. If we were looking straight down at our figure, we would see the tops of all of these cubes. So if you were looking straight down at it, you would see 2 in this corner piece and then another 2 coming out to the side. So that would obviously look like A. Because looking straight down on it, you wouldn't be able to tell the depth, that there's a different depth to these. Okay, and that's all we have for notes for today. Super easy, super short.